Hail forms through a complex process involving strong updrafts within thunderstorms, supercooled water droplets, and the cycling of particles within the storm. Here's a detailed explanation of how hail works. Strong updrafts. Thunderstorms with particularly strong updrafts are necessary for hail formation. These updrafts can lift water droplets high into the atmosphere where temperatures are below freezing. Supercooled water droplets. As water droplets are carried upwards, they encounter temperatures below 0 degrees Celsius, 32 degrees Fahrenheit, and become supercooled. Supercooled water remains in liquid form even though it is below the freezing point. Ice nuclei. When supercooled water droplets come into contact with ice nuclei, tiny particles such as dust or other small ice particles, they freeze instantly, forming small ice pellets or hail embryos. Growth by accretion. These hail embryos are then lifted by the updrafts through the supercooled region of the storm, allowing them to collide with additional supercooled droplets. The supercooled droplets freeze upon contact with the hail embryo, causing it to grow in layers through a process known as accretion. Updrafts and downdrafts. Hailstones are often cycled within the storm cloud by updrafts and downdrafts. As they are lifted, they continue to grow by collecting more supercooled droplets. When they become too heavy for the updrafts to hold, they may fall, only to be caught by another updraft and lifted again. Layering. Each time a hailstone is lifted and falls within the storm, it can acquire new layers of ice, leading to the onion-like structure seen in cross-sections of large hailstones. Size determination. The size of a hailstone is determined by the strength of the updrafts in the thunderstorm and the amount of time it spends cycling within the cloud. Stronger updrafts can produce larger hailstones because they can keep larger particles aloft for a longer period, allowing them to collect more layers of ice. Fall to the ground. Eventually the hailstones become too heavy for the updrafts to support. When this happens, they fall to the ground, potentially causing damage due to their size and the speed at which they fall. Storm intensity. Stronger thunderstorms with more powerful updrafts are more likely to produce larger hailstones. Temperature profiles. The temperature profile within the storm, including the height and thickness of the supercooled layer, is crucial for hail formation. Moisture content. High moisture content within the storm provides more supercooled water droplets, enhancing the growth of hailstones. In summary, hail forms in thunderstorms with strong updrafts that lift supercooled water droplets into the upper regions of the storm. These droplets freeze upon contact with ice nuclei, forming small ice pellets that grow through repeated cycling within the storm cloud. The size of the hailstones depends on the strength of the updrafts and the availability of supercooled water. Once the hailstones become too heavy to be supported by the updrafts, they fall to the ground, sometimes causing significant damage. If you enjoyed the video, give it a thumbs up, comment, and share it with your friends. Don't forget to subscribe to our channel and hit the bell so you never miss a new video.